Hello and welcome back. In my last video I was cut off right at the end of this question, so I want to continue looking at this very quickly. So when we're given a polynomial and we want to evaluate the polynomial at a particular value, at c, which in this case is going to be -4, we can use this trick, which is to divide the polynomial by x minus c, or in this case this would be x minus a -4. So we did this. We took our polynomial and we divided by x plus 4, and we went through all of these steps, and we found that the remainder, when we tried to divide this, was -105. And our theorem states that whatever the remainder is, this is in fact equal to f evaluated at c. So in this case, f of -4. So we have that our remainder, which is -105, is f of -4. Now the thing is, we can check this. This is something that we know how to do. F of -4, this is going to be 3 times -4 to the third power plus 4 times -4 squared minus 5 times -4 plus 3. So let's simplify this. -4 times -4 times -4 is -64. And if I'm multiplying this by 3, I'll get 192. In fact, -192. -4 times -4 is 64. This is 16 times another 4 is 64. -5 times -4 is 20. And we'll add another 3. So this is going to be -192. 64 and 20 is 84, plus another 3 is 87. And when we do this, we get -105, which matches our answer. So we did it correctly. Both of these methods will work. You can plug in the -4 directly into the function and evaluate it, but it's nice to know that there are other ways of doing this. We can simply divide by x minus c, which in this case c was -4. So we divided by x minus c to get our function evaluated at that point. So this is quite a nice trick. Now there is something else that we can say here. So when we divide by x minus c, we get f of c. It's the same thing that we get if we plug c directly into our function. But sometimes the remainder is 0. And when the remainder is 0, this means that our function factors nicely. So instead of having this plus remainder term out here, we don't have that. So now our function is just f of x is equal to this factor times this factor. So if I want to factor a function, it would be nice if I could find something whose remainder was 0. And there's a lot of information in here. So let's summarize exactly what this says. Let me scoot this over so my face is out of the way. So first of all, if f of c is equal to 0, this means that the remainder is equal to 0. That means that this polynomial is a factor of f of x. So we can factor easily when we know the zeros of our function. Likewise, we can go in reverse. If I know that x minus c is a factor of f of x, then c has to be a 0 of the function. So this gives us one more technique to find zeros of a function, so that, for instance, we can graph them. Or this gives us one more technique of factoring a function to look for the zeros. So the factors of a polynomial and the zeros of a polynomial are highly related to one another. So So let's do a more explicit example of this. So let's solve 15x cubed plus 14x squared minus 3x minus 2 is equal to 0. So right away, ignoring the rest of the question for a moment, right away they're asking us to solve for the zeros of a function. They just want to know for what values of x can I plug this in to get 0. Okay, and we're told a little bit more. We're given that -1 is a 0 of this function. Well, they already gave us an answer. If I plug -1 into this function, I get 0. This is what they tell us right away. And the reason they do so is because we know -1 is a 0 of the function. That means I can factor this easily using our factor theorem. Knowing a 0 of the function means that I can find one of its factors right easily. So here, what this says is, since -1 is a 0 of this function, then x minus -1 is a factor of f of x. So what does it mean to be a factor? So x minus -1, this is the same thing as x plus 1. So f of x is going to be equal to x plus 1 times something. I don't know what that something is, but it's the quotient. So I can figure what this is, though, because if we divide both sides by x plus 1, I know that f of x divided by x plus 1 is equal to my quotient. So let's figure out what this quotient is. So what I'll need to do is take my function, which I have moved up off the top of the page, which is 15x cubed plus 14x squared minus 3x minus 2. And I'm going to divide this by x plus 1. Okay, and then this will give me my quotient. So I look at the first terms. 15x cubed divided by x is going to be 15x squared. So I'll write this over the squared term. 15x squared times x is 15x cubed. 15x squared times 1 is 15x squared. And I will subtract these, so I will get negative x squared minus 3x. Well, x divides into negative x squared to give negative x. So negative x times x is negative x squared, which is good, they match. Negative x times 1 is going to be negative x. So now I'm going to subtract negative 3x minus negative x. Minus negative x is the same thing as adding an x. So negative 3x plus x is negative 2x minus 2. So when I divide this, I'm going to get minus 2. So minus 2 times x will be negative 2x. Minus 2 times 1 is going to be negative 2. And we get a remainder of 0. This is good. This is exactly what we want. We know that if I divide f of x by x plus 1, I'm going to get a quotient with no remainder. No remainder. Everything is working out. So why am I doing all of this? Maybe I can fit this in right here. So what's the point? I'm trying to find when this is equal to 0. And what I've just been told is that I have two factors of f of x. One is x plus 1, and one is this quotient right here. So we can write the following down. 15x cubed plus 14x squared minus 3x minus 2. This is in fact equal to x plus 1 times 15x squared minus x minus 2. So this is a nice equation because I factored this into smaller pieces. So let's continue working with this. So we have our function, I want this to be in white. We have our function 15x cubed plus 14x squared minus 3x minus 2 is equal to x plus 1 times 15x squared minus x minus 2. I want to know, when is this equal to 0? Well, the product of two numbers is going to be 0 when one of them is equal to 0. So, this is easy to solve. This is x is equal to -1. Or, and then I've got this big mess. And to save some time, I'm just going to use the quadratic formula. So x will be equal to, so our b, let me write these down. So we've got a is equal to 15, b is equal to -1, c is equal to -2. So x will be equal to negative b, so -1, plus or minus the square root of -1 squared minus 4 times a times c, all divided by 2 times a. Let's simplify. Let me move this over. So -1 is 1, plus or minus. So we've got 1 is -1 squared. We've got two negative signs, so this will be plus. 4 times 15 is 60, times 2 is 120. 2 times 15 is 30. Simplifying this more, 1 plus 121 is, 1 plus 120 is 121. And that is a perfect square. That is 11. So everything simplifies quite nicely. So if I have the plus sign in there, I'm going to have x is going to be 1 plus 11 over 30, which is the same thing as 12 30ths, and both of these are divisible by 6. So this will be 2 fifths, or x will be 1 minus 11 over 30. 1 minus 11 is -10, and -10 30ths is the same thing as -1/3. So we've just done a lot of work to solve a question. Let's go back up to the question really quick. I want to solve when this is equal to 0. So when I have a polynomial, one of the easiest ways to solve it is to factor it. Well, we were told a 0 of the polynomial, which means we know one of the factors already. So because we knew that one of the factors was this, I could solve for the other one. And once I know all my factors, if I want the product of two things to be 0, either one is 0 or the other one is 0. This one is easy to solve, so x is equal to -1, or, and then I just use the quadratic formula. So what are my answers? X is equal to -1, or 2 fifths, or -1/3. And there you have it. All you ever needed to know, and probably a lot more than about factoring polynomials.